Today we're going to start with the basics of tangents and secants. And I'm going to show you some examples of tangents and some examples of secant. First, let's talk about the definition. We already know the definition. The tangent is a line that lies in a plane of a circle and intersects the circle at exactly one point. So it's not going to cut through the circle. It's just going to touch the circle at one point. So a line that lies in a plane of a circle and that intersects the circle at exactly one point. Alright, so if I have a circle, by the way, we name a circle by its center, so we'll call this circle A. And a tangent line is going to touch that circle at exactly one point. We'll say point B. It does not cut through the circle. It touches the circle at one point. All right, so then that brings us to secant. A secant is a line that contains a chord . It intersects a circle at 2 points. So if I have a circle, and we'll call this circle C, then a secant is a line that goes all the way through the circle and it intersects the circle at 2 points. So it's going to go through, so it intersects at 2 points. Also notice how it extends through the circle. If it doesn't extend through the circle, D and E are a chord, but the line DE is the secant. Okay, so we're going to talk about tangents. And the point that the tangent touches the circle is called the point of tangency. So if we're going to use this picture, the tangent is this whole line TX. Remember, we denote a line by drawing the arrows on the end to show that it extends forever. The point of tangency is point T, a point interior to the circle. That means on the inside of the circle. There's 2 points inside the circle. P and I are both points inside the circle. Point exterior are points outside the circle. You cannot count T because T is on the circle. Exterior, the only point exterior is X. T is not inside or outside, it's on the circle. Alright, so point T is the point of tangency because that's where the tangent line touches it. P and I are points inside the circle, so they are interior. X is exterior. Okay, so that brings us to a theorem. It says if two segments from the same exterior point are tangent to a circle, that means they touch the circle at one place, then the segments are congruent or equal to each other. Okay, so this point Y has this segment ZY and a segment XY. Since both of these are tangent to the circle, the point of tangency here is X, the point of tangency here is Z. then these two segments are equal because they start from the same point. If they start from the same point and they're tangent to the circle, they're congruent. So that means these two sides are equal. So if I were to tell you that this segment, xy, is equal to 4, then zy must also be equal to 4. All right, so let's solve a problem. They share a point P, which is exterior, that means outside the circle, and they are tangent to the circle. And what I know is that QP has to be congruent to RP from that theorem. So I know 2x minus 3 equals 27 because they are equal to each other. And I'm going to solve for x. So I add 3 to both sides. And I get 2x equals 30. Divide by 2. And x equals 15. If I put 15 in here, 2 times 15 is 30. Minus 3 is 27. All right, so let's try another one. I don't know anything about this. This is not tangent. This 52 is not tangent. Tangent touches the circle at only one point. This already has touched at 2 points, so it's not tangent. This is tangent, and this is tangent. So I know 2x minus 13 equals 48, and I'm going to solve that. So I get 2x equals 61. Then when I divide by 2, x equals 30.5. And you can plug that in. 2 times 30.5 is 61. 61 minus 13 is 48. Okay, so it says when circles are inscribed in polygons, the polygons are said to be circumscribed. So this word circumscribed means that the circle is inside the polygon. See how it's inside the polygon, it's touching the sides? Now look, we have all these points of tangency. So I have this point, and since it's tangent here and here, I know this side length and this side length are equal. So I know KT and TL are equal. Since this is a shared point, I know WK and WM are equal, or congruent, I should say. Since this is a shared point and they are tangent, I know that LR and MR are congruent. So these two are congruent to each other, these two are congruent to each other, and these two are congruent to each other. So it says triangle TRW is circumscribed about circle A. If the perimeter of TRW, so this whole triangle is 50, so this side plus this side plus this side is 50, and TK is 3, so this little piece here is 3. That means this little piece here is 3 because they're congruent. And WM, let me find WM, is 9.5. That makes this 9.5. Find TR. So they want this whole side length. Well, first of all, remember all the sides. Each one of these pieces is going to add up to 50. So I know 3 plus 3 plus 9.5 plus 9.5 plus x. We'll call this x, and they're the same thing. They're congruent. Equals 50. So we'll add it up. This gives me 6. This gives me 19. 6 plus 19 is 25. You can do that in a calculator. Plus x is 2x equals 50. I'm going to subtract 25 because I'm solving an equation, and 2x equals 25. Divide by 2. And x equals 12.5. So what is x? X is this piece here and this piece here. Now, the question is about this whole length right here, which is 3, because this piece is 3, and 12.5, because this piece is 12.5, which gives me 15.5. So the length from T to R is 15.5. Now you're going to write at least 3 sentences that describe what you learned in this video. And then you need to write at least 1 question. It can be a question that you have that you don't understand or you need me to explain more, question you think I might ask you, or something else that's relevant to this lesson.